streaming. Let me go to YouTube. Okay, so let's see. Okay. Okay. Let's see now. Let me share the live stream really quickly.
Cool.
All right. Yeah, so I just started. So let's yeah, let's go. Yeah, so tell me a little bit about yourself and everything and what I can do to help you.
Cool. So I've been studying for the interview off and on since maybe April of last year, and I really found your guide interesting, and I found that back in November
Mm-hmm.
because I did a bunch of studying. I found a link on Blind where it's top 75 questions to save you time on LeetCode.
Mm-hmm.
It studies all the patterns like arrays, dynamic programming, trees, etc.
Mm-hmm.
So I studied, and then I got to the point where I was reviewing all the material again, and I found that things weren't just clicking, or I had forgotten what I learned. So
Mm-hmm.
then I read a interesting thing on your guide where it said, do the problem until you're sick of it, until it's autonomous and you know the patterns right away.
Mm-hmm.
Uh, so from there, I made a sheet, a text document where I many more times.
Okay.
So what I want to get out of this is like, um, since I'm just practicing by myself, I need the input from someone else besides my own eyes, because I feel there's some missing gaps that could help me patterns. So
Mm-hmm.
now this is based on your guide. So you said to do grokking, but instead of grokking the the programming patterns, I'm doing the top 75 questions on LeetCode. I'll send you the link later,
Mm-hmm.
just for reference. So right now I'm in the section where where I'm going over the dynamic grokking the dynamic programming
Okay.
questions. So after that, I'm going to look at system design, and then afterwards, I'm going to fill in the gap with LeetCode questions.
Got it. So you're in a position where you have been basically studying for a while, but you really are looking to, I guess, redo your approach. I think that's basically what you're trying to tell me here.
Correct. Yes. Correct.
Okay, that's perfectly reasonable. Now the 75 question thing. I understand that this is I've seen the leak code thread myself. And so I understand that it's basically a bunch of questions that companies, or should I say, has been curated by companies. And grouped up, like saying Amazon will ask you these types of questions and Facebook will ask you this amount. Is that basically right?
More or less, yeah.
Okay.
But the guide doesn't tell you. It doesn't. It's not for a specific company. It's just more general, I would say.
Okay. So these are all general questions, right?
Correct. Yeah.
Okay.
Basically.
So then what do you find that you're consistently doing wrong? Like, what are you messing up on?
Um, I when I approach some problems, sometimes I get stuck where I say, "Oh, I've seen this question before. Can I apply it?" And then I'm stuck where I'm trying to remember how that pattern looked or what was the trick, because some questions have certain tricks. So sometimes I go down that rabbit hole and I just get confused and stuck on the problem.
So you find yourself getting trapped in like a preconceived notion of a pattern. Is that basically it?
Yeah, exactly correct.
Gotcha. So, and you find yourself that sometimes you get pigeonholed into a lot of these patterns. Like you have a idea of what you want to do, but then you execute on it, and then turns out, oh, that's not really what it is.
Correct. Yep.
Okay, so you have a tendency to jump to conclusions. Now, that's
Mhm.
a pretty common issue. And what kind of problems do you really find are make you vulnerable to this? Is it like a recursion problem that you usually run into, or is it just like in general, like you could get hit with this on arrays, or what's the tendency here?
I would say it's like fine. Um, I would say I would say graph problems and recursion. And
Hmm.
for example, here's a bunch of triangles, find a certain area.
Hmm.
So I would say that links towards dynamic programming as well.
I see. Okay, so dynamic programming is not really that. How do I describe it? It's not very useful in and of itself for me to determine things. Usually, dynamic programming is almost always its own separate thing, and really, that can go into a whole spiel about that. But what I'm really trying to nail down here is to make sure that you do not pigeonhole yourself, because based on what you've just told me, it sounds like you have two problems going on. The first one is your preconceived notion of the patterns. The second one could also be your handling of more complex problems as well that require, multiple steps, because very much recursion has this tendency to be broken down into like a base case and then a recursive case, right? And
Correct.
based on what I'm hearing, it sounds like you might also struggle with that as well.
Mhm.
Do you find
Right.
yourself struggling with recursion in general?
Uh, yes, I've been practicing more as of recently, so I'm slowly getting there.
Okay, that's fine. So what I can do right now for you is let's warm up with a very simple problem, and then let's see where this goes. So I'll share with you the doc,
Okay.
and then we can get started. Oh yeah, and shout out to the live stream. Thank you, Caesar, for doing this. By the way, it's not every day that people will actually offer to have their coaching sessions live streamed. So you know what? Thank you so much for letting me do this.
Cool. No problem, man.
Yeah. Okay, so I sent you the link in the Zoom chat. Can you type in it?
Let me open this on Chrome. Okay.
Okay.
Cool.
All right. So let me pull up a question for you. I know which one I want to give you. So, uh, let's do this one. And let me know if you've seen this problem before. Um, and I think for people who are on live stream, if you've probably seen this problem before as well. And I recommend that you guys follow along, try to do the problem as well, because um, you know, you might have seen it before, but you can also fuck it up. We've all been guilty of that. Okay, let me pull up the timer again, which I lost. Where'd it go? Too many windows to manage. All right. There we go, stopwatch. Okay. Clear it out, and here we go. Yeah. So I'm going to give you a red tape and a set of blue tapes. A tape is an interval x and y. So we're going to first stick that red tape on a table and then stack it with a bunch of blue tapes. And I want you to determine if that red tape is still visible underneath all those blue tapes. So, what do I mean by this? Let's suppose I gave you a red tape that started from interval 3 and ended at 6. And then I gave you a bunch of blue tapes that start at 1 and 4 and then 5 to 8. Now, the red tape would be visible here because there's a section between 4 to 5 that shows the red underneath. And that, but if I were to change it up and said that there's interval 1 to 5 and then 4 to 8, well, the red tape is not visible at all because it's all completely covered up by the blue tape. Does this make sense?
Yeah, yeah.
Perfect.
Okay, so blue 1 to 5. Okay, so yeah, this is if I have to pattern match this to something, it's either a merge interval question along those lines, not merge intervals necessarily, but let me see. So you're basically, let's see. So if I red 3 to 6, okay, so. When the red tape is visible. Okay, so you have your blue tape. It's looking at the first example, 1, 2, 4. Okay, 5, 2, 8. Wait, so I'm trying to understand. Okay, so for this example, from 1 to 4. Okay, so red goes on top. I'm reading the description. Given the red tape, first stick the red tape, then stack the blue tape. Okay, so first stick the red tape on the table and stack the blue tapes. Okay, so the red tape first goes. Let me just draw some examples just to get this going. Three to 6. Okay, so first stick the red tape. Oh, okay. So first, given a red tape and a set of blue tapes, first stick the red tape on the table and stack it with blue tapes. And if the red is visible. Okay, for this one, I have to see if the intervals overlap. And for that, I'll just use color scheme here. Just kind of hard to think right now. Red tape and blue tape. Okay. Okay. Apparently the red tape is visible. Okay, given a set of blue tapes, a tape is the interval XY. Blue tapes. So it's a little ambiguous, because you say you first put the red tape and then you stack it with blue tapes. excuse me. So how's the red tape? How's the red tape visible if you first put it and then you do 1 through 4, and then from 5 to 6? That seems that it would overlap it, correct?
No, so consider that the start and end interval, right? So if I put this on a number line, right? So I have, let's say, for instance, 1, 2, 3, 4, 5, 6, 7, and 8, right? And then I have my interval from 3 to 6, right? So let's underline it to be blue. I have my interval from 1 to 4. Let's highlight that. And then 5 to 8, right? There's this little interval between 4 to 5 that is not being covered. Do you understand?
Mm-hmm, mm-hmm.
Yeah. And that's why the output is going to be true. Because you can still see a little bit of interval between 4 to 5.
One, two, three, 4, 5. Wait, can you repeat that again?
So, let's say I made my tape here, right? I highlight it to be red, 4 to 5. Oh, sorry, 3 to 6, right? This is going to be my, let me go ahead and, let's make it red and black for very, very simple, reasons. So, I have 3 to 6, that is red taped. 1, 2, 3, and 4 is going to be blue taped, right?
Mm-hmm.
5, 6, 7, 8 is going to be, blue taped. But 4 and 5, this little area, like say if I had, for instance, something called 4.5, then that will not, that belongs to a red tape, but it is not covered by blue tape. Does this make sense?
Okay, I see. Okay, so the ranges are inclusive, right? They don't overlap necessarily. Like you can have fractions, like if we look at this like a ruler. Is that what you're trying to say with the 4.5?
Yeah, I just use 4.5 as an arbitrary point, but you should consider the ends to be non-inclusive. So that, well, actually, what do you think would be the right answer here? Would you consider ends inclusive or not, and why?
From the example, excuse me, from the example, they should be inclusive. But that middle part, I guess the range 3 to 6, that's inclusive of red. So that's why there's going to be a gap between 1 to 4 from 5 to 8. So that I see what you mean there now. Okay, so so I'm trying to pattern match this to a interval problem. So from 1 to 4, so it's basically asking because for that condition, the 3 to 6 overlaps, or you can merge it into the existing blue intervals. Okay. Okay, so you got 1 to 4. There's still gonna be red in there. Oh. Yeah, so this is so right now I'm stuck. I'm like because I've seen some some interval questions, so that's getting me stuck. So I'm trying to get unstuck here.
So don't think, my tip here is do not think about this in terms of patterns or whatever you have seen before. I want you to disabuse yourself of any preconceived notion, like pretend you've never had done a LeetCode problem. I want you to focus on trying to do this step by step. Build up the argument. Prove to me from a very simple idea that your idea works, and then from there be able to drive it in a systematic way and then write the code. Does this make sense?
Okay, yeah, that makes sense.
Yeah. Start from scratch. Pretend you're explaining this to a small child.
Okay, doing the red tape. Okay. Okay, so the first step is to lay down the red tape from 3 to 6. It's here. And then afterwards, you look at the blue intervals 1 to 4. And then 5 to 8, you put that over the red tape. Okay, so the tape is going to go from 1 to 4 exactly. The start and end range will be included in this step. So 3 to 6, that means that includes everything. 3.5, for example, is going to be included. 4.5 is going to be included as well. So you can see the gap from 1 to 4, and then from 5 to 8. You see those two intervals; they're not fully connected. So you're gonna still be able to see red tape. What else was there? So now I'm looking at the second example, 3 to 6. 1 to 5. Okay. Okay, the blue example. Okay, so for the second example, you lay down the red tape from 3 to 6, and then the blue. I don't want to try to get ahead of myself here. So the blue from 1 to 5 and 1 to 4. Why don't we merge that interval, right? Just lay it down. You have one long interval, and then you're able to check the red ranges. You see that it's not visible at all because it's all inside the range in the blue range.
Okay, so you're trying to merge whatever overlapping blues that you have beforehand, is that right?
Correct. Yes.
Okay, well, you haven't told me your core algorithm yet. All you've done is just thrown at me ideas, but you haven't given me like a step-by-step of how you intend to solve the problem. Oh God,
Okay.
please do not comment on the Google Docs, guys, please.
Okay, my core algorithm. So let's say we want to use the least amount of blue possible. My first step is to merge all the intervals in the blue ranges. And then after that is after you merge the intervals in blue, you wait. Let me see. Do you lay down the red tape first? Okay. After you merge the blue intervals, you're gonna check the red, and you're gonna check if coincides between the blue ranges, and that's how you're gonna be able to determine if you can still see red.
Repeat that? I didn't quite understand. Put it in simple language for me.
Okay, so you have you're gonna have a bunch of ranges for blue.
Mm-hmm.
So why don't we combine or merge all those ranges? So we do the least amount of cuts for the blue tape.
Okay.
Then you can see so now the next step is checking if you can still see red. So based on those intervals, you're gonna see if you can still see red within that range. Mm-hmm. But so now I'm stuck on trying to determine how is it that you're gonna see red. So you're just checking if it's within the blue range.
No, we're trying to see if there are any reds underneath, right? So you're saying within the blue range. What do you mean by this? Again, imagine I have, let's start with a very basic case. I have one red tape and I have one blue tape. How do I know there is any red showing up?
That's if it's outside the range of either the start or the end of blue.
So you want to see, so you're saying if the red interval is inside the blue interval, right?
Oh, no, no, no. You're gonna see if the red is outside the blue,
Okay.
outside the start or end interval.
Okay. So what do you mean by this? Suppose like let me give you a very very basic example here. Two pieces of tape, one red, one blue. How do you determine if a red is showing up?
Um, okay, so for this one, damn, okay, let me. Uh, for this one, I'm just gonna check. I'm gonna check if the range is outside the blue from 1 to 4. For example, let's say we have 3 to 6. 3 to 6. And we have 1 to 4 for blue. So let's say this is an array. If the array outside the 1 to 4 is filled out, then we know that you can still see the red.
Okay. Yeah. So if there is a little bit of red showing up, if these intervals don't exactly completely overlap, right?
Correct. Yeah.
So, okay. So that's the first step. You just need to see if these intervals overlap and by how much. Now, if there is any overlap, how do you determine how much of the red is showing?
Okay. How much of the red is showing? So for that, what I'm gonna have to do is I'm gonna take the end and the start of each of these.
Mm-hmm.
For example, yeah, right. It's kind of hard to since I'm so used to doing these problems on paper. It's kind of hard to visualize this.
Don't try to visualize
Okay,
it. I want you to write it down.
okay. So you want to check the overlapping red. So for that, so you can do blue. Okay. So that's for the right hand side. You do end blue minus start red. That's going to give you how much it overlaps. But then you want to do that also on the left side. And for that, you're going to do okay, so for this one, and blue minus. Oh, no, that's wrong. Wait. So end blue, start red. No, that should be end red. End red, because you're doing 6 minus 4, and that's going to give you the overlap of the right hand side. And then the left. So you're trying to see how much it overlaps for red. So for this one, let me see the start blue. Yeah. So for this one, we're gonna ignore it if the value is negative.
Okay.
That means that it does not overlap.
Mm-hmm.
So So for the other case as well, let's say we have, oh, like that. Oh man, I have to start doing these problems in Google Docs because it's kind of, okay. So that's going to apply to the right-hand side as well. If a value is negative or 0, that means that there is no overlap.
Okay, well, here's the thing. You're comparing left side and right side, right?
Correct.
So what happens if I give you something, I don't know, like just for the sake of sanity checking, let's say I gave you 5 and 7 here. What do you do here?
And blue. Oh, okay. I see what you mean. Yeah. And blue 7 minus 6 is going to be 1. There is no overlap. So yeah, that the logic is wrong there.
So how do you want to fix it? Because there's a bunch of different ways red and blue can there's a bunch of different ways red and blue can overlap. So how do you intend on handling each one of these states?
Let me see. Okay, so this case where blue is greater than, okay, if blue end is greater than red end, that means that there is no overlap. So that case we won't have to compute.
Wait,
For
hold on.
example,
Repeat. You said if blue end is greater than red end.
okay, correct. So okay, so to compute the right hand side, you do 7 minus 6, right? Blue end minus red end.
Okay.
Oh, okay. Oh, okay. 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 So for that case, just thinking about this some more. Blue minus red, 7 minus 1, that's a positive number. They don't overlap, so red is not going to show in this case. So, okay, what I have to do for this? So 7 minus. Okay, so for this case, I see that the blue end is greater than red end. It's going to yield a positive number, which means that red is not going to show anything.
But then you have this left hand side, 3 to 5. Red's going to show something.
Okay, okay. I see.
I'll tell you what, I'm going to give you another 5 minutes. I know you're not going to get through this problem, but at least get through this step and we can talk a little bit about it.
Okay, okay. Okay, so here what I would do is I would do red end minus blue start. If the number's positive, that means that there's an overlap.
Okay.
Okay, so okay. Okay. So red and blue start. Okay, so I have to take into account both the start and the end for these intervals. Blue. Okay, so okay. Okay, so here we just want to see if they overlap, correct? So I'll just take the rear end minus blue star. It's positive, that means that there's an overlap. You're still gonna see red. Yeah.
Are you gonna throw in the towel on this?
Yeah, fuck it.
Okay. Okay. So basically, yeah, what I saw was that you tried basically spending 15 minutes just throwing a pattern that you knew at the problem, and you couldn't figure it out, and and this is essentially where you started crumbling. You didn't know how to break down a problem from its very basic roots, and you don't understand how to get the roadmap of where you want to go. And that's why, if you break down this problem at its very, very core, this problem, all it is just a do intervals, how to tell if two intervals overlap. This is the core of it, right? Do two intervals overlap? So, and from what I saw, you can't answer this question. This is like a very basic, easy level question I would ask on a phone screen. So, let's actually figure out how to do this, because what I'm going to do is I'm not going to show you the answer. I'm going to show you how to derive this answer. So, let's say I'm given two intervals, right? X comma Y, A comma B. Well, the question now becomes, how do two intervals overlap, right? So let's say I have my X and my Y. So, and then I have my A and B, right? So a few ways that these can arrange themselves. Let's say that it could be like this, where X is leading AB. Let me actually insert a page break. I could say overlap over here, or they can completely miss. Like this. So there is 1, 2, 3, 4, 5. 5. It could be like A is fully contained within this, or the sixth way is that X and Y is completely contained within A and B. Now, this is very easy to figure out, right? All you have to do is just come up with a rule set that fulfills these 6 conditions. Does that make sense? Because these are all the only possible ways that these can be possibly overlapping or arranged, really, because some of these cases do not overlap at all. So, and this is like at least the first step I would have wanted to see from you. What you were doing is you were trying to go one example, come up with a rule, and then hope that the next example would be somehow conforming to this. And this is essentially where you got stuck. You committed yourself to a rule, and you didn't know how to adjust or be able to, you don't know how to derive a problem holistically. You only know how to solve a problem, one problem and one problem only. Now, if we look at this, we can see that the conditions, what do you see as the common pattern for whether or not these intervals overlap?
You can see that the end, for example, B is greater than X.
Okay.
So you take into account the start, the end and the start of the intervals.
Okay.
And then you can compare them if they overlap. So, for example, if X is less than B. If X start is less than B end, um, there's going to be an overlap there. And also for the second example, Y start A start is less than Y.
So you're saying if X, so why don't you formalize that rule for me down in the bottom?
Okay. Okay. So let's say call this interval one dot start.
Just use X and Y notation for now, because this is what we're
Okay.
working with. Don't overcomplicate
Okay.
it. Keep things very, very simple right now.
Okay. So if X is less than B,
Okay.
um, so that's the first case, and the next one is if Y is greater than A.
Okay. So you would say that as long as you have these, that you would that it would fulfill all 6 of these conditions. That
Let me see. So let me see. Let me look at number 3 since they don't overlap there.
okay.
X. Okay. X is less than B. No. Y is greater than A. No. Let me see number 5. I'm in example number 5. X is less than B. Yes, it is. Y is greater than A. Yes. Okay. Okay. So yeah, we're just checking if they overlap. So yeah, that would be the scenario there.
Right. Now,
You check. Mhm.
sorry, go ahead.
No, you would check the both the X B versus the Y and A.
Okay. How long did that take you?
Like a minute or two.
Yeah, like 3 minutes. The moment
Yeah.
we drew out every single possible scenario for this, it was like instant. Except what you did, you spent basically 10 minutes up here trying to figure out the rule itself. So the first thing is really,
Yeah.
when you don't know, why don't you just draw out all the possible cases and find a rule that conforms to all the cases? This is what I'm talking about when I said at the very beginning that you were unable to really understand a lot of the simple fundamentals of problem solving. And I think if you watch in one of my videos, I say to, at the core of it, draw it out and derive a rule set. So, of course, you can translate this into interval 1, interval 2. Right now, we're talking purely in the abstract right now. So,
Right.
that being said, how does this get us to where we want to go, right? Well, in order for us to be able to come up with whether or not a red is still showing up, it would basically imply that once we have taken away or covered up this red, we still have this much red to take care of. So what do I mean by this? So for instance, let's say I have X and Y, A and B. So once I chop off A and B, then I still have to take care of these reds that are dangling. Does that make sense?
Right.
I need to find some blue tapes that will be able to cover this up. On another example, if these don't overlap, then I still need to be able to handle this red tape here. Same thing here. I just chop off whatever segment is covered by A and B, and then move on. So, what does this mean? This means that our roadmap is we get a red tape and blue tape, chop off whatever red tape is covered up by the blue tape, and then rinse and repeat. Now, you would agree that this core algorithm would essentially work until we have no more red tapes.
Correct.
But can you see how I was able to derive this actual solution from a very simple demonstration of how we would actually do this in, like, per se, real life?
Yeah.
And so this is what I want you to get into your mind if you get anything out of today. Be able to explain the problem on a very basic and simple level. And I think if you had done this, I think the answer would have come to you pretty quickly. Maybe not instantly, but at least it would have been better than thrashing around like this.
Right.
So, And basically this is where we're gonna leave off right now. Do you want to try and continue the problem here? Because I think now that I've given you the basic, I want you to go forward here and knowing that this is basically your algorithm. How do you improve on this, or at the very least, how do you write the code for it?
Okay, so we get a red tape and a blue tape, chop off whatever red tape is covered by the blue tape. Okay, so by chop off, you mean you want to find the intervals that overlap?
Well, yeah, let's follow this algorithm, right? We have a red tape and a blue tape. We
Mm-hmm.
chop off whatever red tape is covered up by the blue tape, which means that we have some red tape remaining, right?
Right, right.
So then after that, you need to be able to put that red tape back in the pool ready for next comparison. So
Mm-hmm.
I
Mm-hmm.
want you to write the algorithm for that.
Okay, so okay. Okay, so let me look at these examples. Okay, so let's have yeah, red tape. Chop off whatever red tape is covered up by the blue tape.
Mm-hmm.
By that, let's first see if they overlap, and if they overlap, that's where we're gonna do the cutting off. So, so so this is assuming there's only gonna be one red tape, correct, based on our input?
We just have one red tape and one blue tape for now,
Okay, okay,
but we're gonna expand this.
okay. Okay, so let's find where the okay, so first we chop off whatever red tape is covered by the blue tape. Okay, so comparing the red tape to the blue intervals, you're gonna modify that modify the red tape interval, and that's gonna tell us what is left off basically. Okay, red tape and the blue tape. Okay, so first find where the intervals overlap.
Mm-hmm.
Then modify the okay.
Okay.
Mm,
So the question is, what size is the red tape after we chop it off?
okay, okay,
Because you say modify,
okay,
right? So what's the size of the red tape remaining?
okay. Okay, so for this one, let's see. Let's take okay. Okay, so I'm gonna have to compare all the blue intervals to the red ones. So for that okay, so for that I'm gonna have to iterate over that. So okay, let's okay, so if writing code. Um, so, fuck, why am I stuck again here?
If you're stuck, well, why don't you draw it out? Well, we already drew it out, right? So all you have to do is figure out a
Okay.
rule set from all these 6 diagrams, right?
Okay, yeah, correct. Okay, so looking at the diagram, okay. Let me so I'm gonna look at the examples and then draw out the code. Or
Okay,
shoot.
sure, whatever. I would say come up with a rule. You know how we came up with the x is less than b and y greater than a? Come up with a rule that fits all these. You know, let's walk through it step by step. Okay, so on the first one, we have this condition. Now, what is the size of the red remaining?
It's b minus x. Or no, sorry.
What's the
It's
interval? We're looking for the interval, right?
right. It's y minus b.
Or you can just represent the interval as b comma y, right?
Correct.
Okay, next one.
The next one is a comma y.
Okay, yeah, and you get the idea.
Mm-hmm.
Okay, now knowing all that, can you derive a rule from all these? You can fill it out if you want, but you get the idea. So I want you to derive a rule set for this.
Okay, so for the example we just did, that's the endpoint. So it's okay. So it's gonna be dash y. Then for the second one, it's gonna be yb. It's basically so for that case, it's looking at the both endpoints. So you're gonna go from one endpoint to the next, and then for the other example, there's no overlap. By. Okay, so okay, for 5 it goes from x a and from y. Okay, so
Don't do this in your head.
okay, okay, so for number 1, it goes b to y. That's taking both endpoints. And then for 2,
Like I said, don't do it in your head. Why aren't you writing it out?
okay. So finding the overlap. So interval 1.
question. Are you sure about this one?
Okay, yeah. So you're finding the red that's left over. So in that case, the red's
Correct.
not gonna be left over. That's gonna be dash A.
Okay.
And then for this one, there's nothing.
So the red left over is going to be
For number 3,
for number 3. Yeah. What's the red that's left over?
it's gonna be X dash Y.
Okay.
And then for this one, it's X dash A. That's taking both the examples from on top. B dash Y. And for number 6, there's gonna be nothing. Okay, so how much red is gonna be left over? So red start. Okay, so I'm looking at 5. I'm trying to derive a rule here. So red start to blue start. If we do that, we have to see. Okay, so red start 5. Okay, so I'm looking at number 5, red start, then red start. It goes from X to A, and then it goes from B to Y. Okay, and then for number 6, there's no overlap. Which red is left over?
So number 4, how much red is left?
So for that's going to be X to Y. It's the
Okay.
whole interval there.
And then number 6.
6, 0, nothing.
Okay. Perfect. Okay. So now you have all these. And by the way, just write it out. Yeah. So now I want you to take all these and derive a rule from these. Can you do that?
Yeah, let me see. So X to Y. Okay, so for number 5, X to A. So you start with X, which is red start, and then you look at the start for blue. You see that the start time for blue is less than the end time of red. So you have to take into account that what's going to be left over, which is red start, which is X to A.
Okay.
And that is because the start time of the blue is less than the end of it's less than the end of red. So
Why'd you write the rule out instead of trying to do it in your head?
Okay.
I'm gonna harp on this. Write it out.
All right. If so if red end is less than if red end then blue start. Okay, so blue start. Red end is greater than blue start.
Mm-hmm.
Left over is going to be red.
I recommend you still stick with the X and Y notation A and B because you can always translate this over.
Okay, sure, sure.
Because again, you have written this in the picture. It's just so much easier to work with.
That makes sense. Okay, so leftover, it's
So I'll convert this for you. So Y is greater than blue start, which is A. Okay. So then, okay. So if Y is greater than A, you're going to have an XA. Is that what you're saying?
correct. That's going to be the what is left over.
Okay. Well, can you find a counterexample to that?
Number 6. Okay, yeah. It's not going to work for number 6.
Okay.
Why? And what other condition can I throw in this? So number 5, if A is less than Y, there's going to be an overlap. And
well, keep in mind this is the condition that you need for the overlap, right?
Right. Okay, I see. So if on our example number 5, if is Y is greater than A and X is less than B, okay, so I'm looking at X is less than B, and I'm looking at the examples. If X is less than B, okay, so I'm looking at trying to apply this to the example number 1, for example. So if Y is less than A, if A is less than Y, yes, and X is less than B, yes. Leftover is going to be X to A or AX. Okay, so in this case, I'm trying to see if it's going to handle both sides, both cases. So I see that if Y is greater than A and the X is less than B, okay, leftover is going to be A to X, and what else? No. Wait, hold on.
Okay. So I don't want to waste your time right now. I feel like at this point we're not gonna make any progression. So I'm gonna move you to a different thing. Okay? Because right now, from what I've seen, I thought I could get you to solve the problem just by walking you through step by step, but it seems like you're really, really struggling with this, and that you are not really able to formalize rules based on really simple diagrams and drawing. And this is not a good use of your time or my time, but at this point, it's safe to say that you fundamentally lack a lot of basic problem solving skill. I cannot help you on that part. So what I'm going to do is I'm going to move you to a different problem. This time what we're going to do is I'm going to see if you can at least get the basic idea for another one of these problems, okay?
Okay.
So right now, what I want you to... So let's wrap this section before we move on. So what I really want to see from you is for you to not do things in your head. This entire thing has been just mostly, can you identify patterns? Can you come up with a rule set? And worst comes to worst, can you just come up, even if there was no obvious pattern, let me give you an example. Let me just do this one for you and I'll show you. So the first thing I'm going to say is if these don't overlap, then it's going to be the red tape, right? So what I'm going to do is I'm just going to say, hey, let's eliminate number 3 and 4 by saying, Oops, I'll underline it just so I can strike through it. Wait, where's the strike through? Okay, so I'm going to strike through this and say, hey, if overlap, then what I'm going to do is, like, if they don't overlap, return the red tape, right? That reduces the number of cases that I have to worry about from 6 to 4. Next one. So now I have the one I have to worry about now is going to be what is all this. Now, if they completely overlap, let's say if let's say they partially overlap. So then the answer would just be the max. Let's take 1 and 2, right? If they partially overlap. So in order to handle 1 and 2, I'm going to take the maximum of a comma x, and then the minimum of b comma y. Why is that? Well, let me copy this up here. So if I look at just 1 and 2 alone, I can see that a comma x, it's what between these two options, it's whatever is the bigger one, right? That gets put up here.
Right.
Right? So this is going to be xb, by the way. And a minimum of b comma y. Same thing. It's just whatever, just based on my observation here. Now, the question is whether or not this can work for the rest of these, right?
Mm-hmm.
So if I plug it in here, then I say, hey, yeah, well, this doesn't exactly work because I need x and a and b and y, right? Same thing for here. This doesn't exactly work either. So I'm going to say, like, if partial overlap, then I can return this. Then the last one I can handle here with these very special cases. And then I can just derive a simple rule set for them because I can just say if x less than a, b less than y, or if a greater than x, y less than b. You know, do this, and do this. Really simple, right?
Mm-hmm.
And all I did was look holistically at the pattern that I was using. Now, this is the problem that I saw with you, is that you are trying to come up with some magic wand rule for everything.
Mm-hmm.
This is the problem that, and this is also directed to a lot of people in the crowd, because I know a lot of people have in the chat are kind of like, oh, why is he doing this? The chances are very high that a lot of other people in this chat are facing exactly the same problem, and whoever is like talking shit in the chat or whatever, fact of the matter is that there's someone out there that is facing the exact same problem. So if you feel like you're not getting value from this, fine, man. Just spend your time doing something else. I'm here to help people who really want to learn, and this is all free anyway. So back to this. What I'm trying to show you here is that if you had just taken this problem holistically, step by step, and just did like some simple combinations, simple conditional statements, you would have been able to derive this rule set, and then, you could have optimized on it later.
Mm-hmm.
What you did, and this is like, I'm trying to break your mentality, the preconceived notions that you have, that you are struggling simply because you're trying to wave a magic wand and move on. And what I'm trying to get you to do here is really look at these step by step and construct whatever you're doing from the ground up. Does that make sense?
Yeah.
It's the same story over and over again, really, at this point. It's this trying to figure out this red and blue tape thing. You thrashed around with it because you didn't draw it out. And if you had drawn out, you would have gotten to at least if these overlap. And then the evolution of that is, well, what's the rule set for being able to see what the remaining interval is? Again, just look exactly at the diagram, step by step, choose each one of these conditions. That's it, right?
Mm-hmm.
So, and it's the same thing. It's going to be the same thing going forward. Let me show you where the end of the algorithm is. And this is going to be for everyone in chat as well. It's that, okay, so now that we understand what the leftover remaining red is, then once I have like two blues, then I just repeat the process for every red. Does that make sense? So the algorithm that we would ultimately end up with once we've built on top of this is to iterate. Let's say we have a red queue, right? Which is all the red tapes, and I have a blue queue. For every blue tape, what I would do is I would check against the red tape and pop it from the queue. If there is a let's say that do the overlap operation. If there is a a red tape, there's a red tape remaining, put it back in the queue. Right? And then after that, so this will handle our cases when there is no interval and if there's a split interval. Because we can guarantee that if these were to come back in through the queue again, like XA and BY, these would not overlap anymore and they would just pass through, right?
Mm-hmm.
And then we just keep doing this for every single blue tape. And then in the end, if there is no more red tape, then the blue tape will have covered everything. So you can see how we were able to build this argument up. And this is actually fundamentally becomes the optimal solution, at least in runtime. Now, there are other optimizations that you can do on top of this. For instance, you can pre-check all the blue tapes and merge together. That's one optimization that you can do. Another thing that you can do is that you can actually try and combine the red tapes as well. There's a whole lot more that you could do from here, but the fundamental algorithm does not change. And you can see like how we were able to build that up. If you had just followed this logic, like this here can obviously be improved and whatever. But if you can see like how we can go from a simple question of whether or not these intervals overlap to how much is remaining of the red tape once these overlap is done to, okay, well, what happens if I have multiple blue tapes and I have to start covering up the rest of these red tapes? You can see how the progression of this problem changes and the solution is derived based on all that, just based on these very, very simple arguments and simple considerations. This is how you do real problem solving. It's not by throwing a problem or a pattern at it. It's by being able to fundamentally take each one of these principles and then apply a pattern if needed. If there is no pattern that is applicable, then you just do it by hand.
Okay.
Okay, so let's actually try and do one more problem. And what I'm going to do, since I know that you have like issue with being able to visualize this step by step, what I'm going to do is I'm going to give you a slightly easier problem. This time, what I'm looking for is what I'm going to see is whether or not that you can actually apply what we talked about at a very, very basic level. Does that make sense? I'm not expecting you to get this correct, but what I want you to really, really emphasize, at least for now, and we'll go over the lessons that we have right now, is draw it out. Make it baby step. Very simple arguments. Does this make sense?
Yeah, that makes
Perfect. So then let's say, let me pull up another problem. And I'm not going to time you on this, so very simple one. Given a linked list, reverse alternate nodes and append it at the end. So let's say I gave you a linked list of 1, 2, 3, 4, 5, 6. What I want you to do is return to me back 1, 3, 5, 6, 4, 2. The reason why is because you have 1, 3, 5, because every other node in the list is 1, 3, 5, 2, 4, 6. And then you reverse it, 6, 4, 2. And then you append it at the end. Does this make sense?
Let me see. So 1, 2, 3, where's the alternate nodes and append? Yeah, this makes sense. I did do something similar to this a while ago. You mentioned to tell you if I saw something similar problem or a past problem before.
Okay, then that's fine. But again, the purpose here is for you to do this baby steps. I don't care if you get the right answer. What I want you to do is do this very step by step, very basically and easy to follow. Make the argument.
Okay, perfect. So, okay, so first we have to find the alternate nodes, and once we find those, we reverse them at the end. Let me see, 1, 3, 5, 6. 2 lists are 1, 3, 5. Where's the second list? Okay, so you have a linked list, you reverse the alternate nodes and append at the end. So at a high level, we can iterate over the list. include the alternate nodes into a separate list. And once you have that, you can reverse that list separately with the alternate nodes, and then just link it to the pointer at the end from the first list.
Okay. So what you're trying to do here is basically reverse a second list.
Correct.
Okay. So again, type it out. Type out your very basic pseudocode. Baby steps. What do you
Okay.
plan on doing? Explain to me like I'm a 5-year-old child.
Okay. So I'm looking at the example again just to make sure I have this right. Okay. Okay. So first iterate over this and get the alternate nodes and add them to a second list. Shit, hold on 1 second. Reverse second list. What else? First list tail will point to head of second list.
Okay. So easy. That's easy to understand, right? Well, the thing is, when you say get alternate nodes, what's your strategy for doing this?
So for that, I'm gonna iterate over the list, and I'm gonna maintain a counter.
Okay.
And for example, let's start at 0. Every time you encounter an odd node, you're gonna add it to that list. So let me write that down. So
because there's many different ways of getting alternate nodes. I'm just curious, like what you plan on specifically doing.
Okay. Maintain a counter. Start at 0. Every node, add it to second list. Okay. Okay. So this is a linked list. So we can manipulate pointers or add it to another list.
Okay. So you're going to create 2 lists, fine. Now, I want you to keep in mind, how many passes are you doing on these nodes?
Okay, so it's going to be the initial pass where you calculate the alternate nodes. Then you pass. Then you're going to do another pass on the list to reverse it. And then the append to the end, that's just going to be that's not going to be a pass. So it's going to be 2 passes here.
Right. So right now you have a 2-pass algorithm that runs in order n.
Correct.
Can you get faster?
Let me look. Okay, so how can I improve this algorithm? Let me draw the examples. Okay, I'll just take this one here. Okay, so let's say this is my current pointer. Okay, so I'm just trying to visualize this.
Okay, that's fine. Yeah, visualize it. Again, draw it out.
So okay, so I can manipulate the pointers as I'm traversing it. So for example, 1, I can skip 2, point it to 3.
Okay.
Point it to 4. So this is what I'm thinking. This is what I'm thinking in my head right now. So I can iterate over this list.
Okay.
1. Okay.
You said you said you're creating a second list, right?
Yes, but if we want to achieve, if we want to do better than the two-pass algorithm, we have to do away with that idea.
Okay.
There's really no other way to go around that.
Okay.
That I can think of at the moment.
Okay.
So I know that if I reverse list, okay. Okay, so I can iterate over the pointer. Wait a minute. Okay, so let's say I had a list. Okay, so the way I'm thinking right now, what came to my head is if I have a list node that has all the alternating nodes, and then I have another list head node that includes all the alternate nodes.
Okay.
So for example, in my list head one, that's gonna have 1, 3, 5.
Okay.
List head 2, that's gonna have 2, 4, and 6.
Okay.
So to reverse, okay, so if I do that, I'm gonna have to iterate the list, and I'm gonna have to manipulate the pointer somehow.
So let's put it this way. You are iterating through the list. That's your first pass. You're reversing the second list. That's a second pass. This means that if you want to get it in a one-pass algorithm, you need to simultaneously iterate and reverse the second list.
I see.
Does that make sense?
Okay, yeah, I see what you mean. Okay, so if I have to reverse simultaneously, in our example, how am I gonna 1 to 3? Okay. Okay, so if I have to reverse it, okay. 1, 3, 5, 6, 2, 4, 6. Okay, so let's say I'm iterating over this list. What am I gonna do? Okay, so I'm at the head. I go to the second. What am I gonna do to reverse that?
Okay.
Because this is gonna have to point to 6 somehow.
Okay, but you haven't seen 6 yet. So
Correct.
What's your other option?
So I haven't seen 6 yet. So my next option is go to 3.
Okay. And then you see 4.
Correct.
So then what do you do at 4? You've seen 2. What do you do?
Oh, okay. I see 4. I point it to 2. Because let's say I have a previous variable here. We want to point that. Let's call this the odd nodes. Sorry, yeah. Let's call it the odd nodes. I'm gonna point it to the previous odd node.
Okay.
So if I do that.
If you do that, what happens? I want you to draw it out. What happens in these L1 and L2? Draw it out.
Okay. L1. Let's head. Okay, so let me get some space here. I go from 1 to 2. 2 is an odd node, so I have to maintain a previous variable. So every time I encounter a odd node, I'm gonna link it back to what's inside.
Do it step by step. Remember, you're doing it to ahead of yourself. Very slowly. What we see 1, right? And I want you to be able to do this on your own as well, because you have a problem of getting ahead of yourself. So first, I'm looking at 1, right? I'm gonna add this to the first list. That's what happens. That's basically what your argument is, right? I then have a flag or a counter or whatever. I look at 2. I append it to the second list, right? Third one, I appended to the first list, right? And as you said, fourth one, you appended to the head of the previous one. Fifth one, the same thing. Sixth, etc., etc.
Correct.
You notice how I was able to step through that very simply, step by step? I want you to be able to do this no matter what problem you're on. And that goes for anyone watching the stream. No matter what problem you're doing, you should be able to step through this step by step. Like, very simply, without having to over-explain anything, make hand-wavy logic, and be able to, reorganize and not achieve anything. Because that was essentially what was happening. If you just did this, it makes the conversation so much easier. You don't need to get ahead of yourself. You need to establish, step by step, what exactly is happening. And so, now that you've done that, do you feel like would you be able to write this code very easily?
Right, yeah. So based on your example, list head 2, you can modify your list head 2 to append to the front. So that takes care of the reversing for you. And you just link the tail from list head 1 to list head 2, and you have your reverse list there.
Yeah.
Your example did help there.
Good. The thing is that what I really am trying to get you to consider is that what you're doing is like the hand wavy thing again. Notice that all I said was, hey, you have 2 passes on your algorithm. Therefore, in order to do one pass, you would need to come up with something fantastically complicated, or you can combine the reverse and the traversal that you did in the first step into one step.
Exactly.
That's it. Yeah. That was the very simple logic. Again, you're going for this long bomb YOLO. It's like, oh, maybe I can hand wave some magic shit.
A Hail Mary.
Yeah, you are Hail Marying some random fucking shit I don't even know about. If you had some crazy ass academic algorithm, I would have loved to see that, but you did not.
No.
Yeah, you did not. So, because of that, I want to be able to get you to think like this. Go for the low-hanging fruit. The low-hanging fruit is trying to figure out how to combine the reverse and the iteration pass. Right? That's just based off the logic. I don't want you to do some crazy combo thing. So, now that you've done this, I want to see if you can actually write the code for this. And, now that we've done it step by step, I'm fully expecting you to do this bug-free, so.
Okay. All right. So, let's see. Okay, so defining the variables pseudocode for now. Let's say we're passing what is this problem called? Reverse alternate nodes. Let's say they give us the head of the list here. The traversal. Okay, so let's copy this here. Let's head 1 and let's head 2. So now okay, so occur. So this is going to iterate over the head node. Let's hold on 1 second. Let me fix my browser. Okay, so I have the placeholders list head 1 and list head 2. Let's say let's point list head 1 to list head 1.next to the head.
Why?
Because wait, let me see. Why am I doing that?
Why are you doing this? Again, walk through the logic. So if you're setting this up, you have node, and then you walk through it, then you end up with node 1, 3, 5, right? 5, and then you have, I don't know what you're gonna do for this one. You have 6, 4, 2, and then this dangling head node here. I want you, before you write this, I want you to write out what exactly is going to happen.
Okay, so Okay, so iterate over the list. Maintain a counter to okay, so I have my counter. Okay, see a alternate node. So we're going to maintain a counter for the alternate nodes. When we see the alternate node, add it to the beginning of list head 2. Okay, so let's say.
So you just said list head equals, okay, list head next equals head, fine, all right. So then this means that what you've just done is this, right?
Correct, yeah.
Okay.
Or wait, do I even need list head 1 for this? Let me see, because we already have the head pointer, right? So
Well, you have the head pointer, so what are you going to do?
Yeah. So
before you write any more code, what I want you to do is tell me what exactly is going to happen. Before you write that next bit of code, I want you to write out what's going to happen. So you have said, let's head next 1. Now what?
okay, so let's head 1. Wait, so you made a valid point. I don't think I need list head 1 in this case because you already passed in the head node there. So really all I need is the list head 2 for this case.
Okay.
And I'll just set current cur to head. So I can iterate over the head. And at the end, I can just have head at the end, right?
Okay, write it out. What exactly is going to happen?
Okay, so
draw right out here. You see where my underline is? Write it out here.
Okay.
So you have your L1, L2 head, sure. And then what? No, I want you to actually, that's not what I'm asking you. What I'm asking you is, do you remember what we did here?
Right.
I want you to do exactly that. Do it in the diagram. You have your L1 head and L2 head. How do you plan on coming up with that list? Because our end goal is a list that says 1, 3, 5, 6, 4, 2. And now you have 2 empty nodes. How does this get, how do you go from here to the answer that you want?
Okay, so this isn't going to add it to a list. It's going to, this is going to be a pointer to the, it's going to be a pointer, right? So for this, let me see, let's add 1. So 1, let's say we're at a 0 counter equals 0. Okay, so let's say 1. No, sorry, 1. Let's hit 1. That's we're at counter 0, right? So 0. So there you don't have to add it. The list head 2, which is going to maintain the alternate nodes, we don't have to do nothing for that case. So we're just going to iterate over the list. Go to the next counter. Go to the next node. So in our second example, we see that the counter is 1. It's alternate, which is it's odd. Okay. So LH, like I'm writing pseudocode, and so
be very simple. Do you remember what we did here?
Yeah. Okay. So here we're gonna add a 2.
Okay, you're gonna add a 2 to the head of the node, right?
Yeah.
So then where's the 2? The 2 is gonna be here, not at the behind. It's gonna be here, right?
Mm-hmm, correct.
Okay. Next, what's next?
So the next step is go to the next pointer. It's gonna be even once again. So we added to the end of list head 2. So that's just list head 1.next, point it to the...
Why do you have 2? Aren't you going to put 3 up there? And also, what value is your counter right now?
Oh, yeah, yes. Oh, okay, so... Yeah, so since we added 2, counter is equal to 2 now.
Okay.
Wait a minute. All right, so since let's assume this is 0 based,
Okay.
right?
You want to start over?
Sure.
Okay.
Yeah.
Start over. Yeah. Counter. Okay, what happens to, let's start your counter at 0, right? Clean node. You're going to initialize the nodes here, right? Mm-hmm. So, you have a counter here at 1. What happens? Do you increment the counter or do you not?
So you're going to see that it's even, so you add it to list head 1.
Okay. So even add to list head 1 else list head 2. Sure. Okay.
Correct.
Now what?
Yeah.
Now that you've done this, then what?
Now that you've done that, you update the counter. Counter equals 1 now.
Cool.
You see that the counter is odd.
Okay.
You added it to the beginning.
Whoa. Slow down. Your pointer is still here. What do you need to do?
Yeah. Okay, so we increment counter by 1. So
okay.
We go to the next step.
But this is a linked list. You have a pointer. What do you need to do?
Next.
You need to advance the pointer.
Right, yeah. Cur equals cur.next. Also increment the counter here.
Yeah, okay, so then increment and then advance the point and then advance pointer every time you increment counter. Mm-hmm. Do you see what I mean by you're kind of skipping steps? Again, this is not an array. This is a linked list. Mm-hmm. So, okay, now we're here. Now we're going to follow your rule here. List head, the counter is 1, which is odd. What happens?
Add it to the beginning of list head 2.
Great. Okay. So now you have, I'm going to erase this, by the way. So now you have two here, right? Mm-hmm. And so now at the end, we're going to increment the counter. Mm-hmm. Increment the counter and advance the pointer.
Correct. Okay.
Keep going.
Okay, so now you see that the okay, so we see that the counter is even, so we add it to the end of list head 1.
Okay. So then
we add it to the list.
Why are you appending 2 here? Where's your pointer?
Wait.
Why'd you append 2 here? Where's your pointer looking?
Wait a minute. No. It should be 3.
Mm-hmm. Yeah. Okay. Now what happens?
So now what happens? Go to cur equals cur.next. It points you to 4.
Whoa! What happened? What are we? What is this? Did you skip a step?
Wait a minute. Okay. Advance pointer every time you increment the counter.
Did you increment the counter yet?
No. So increment the counter. We move the counter to 3. Oh wait. 3. Okay. So then you advance your linked list. Mm-hmm. So now we're at 3. We see that okay. So else even add to list head 1. Else add to list head 2. So we're gonna add it to the beginning of the linked list. We're pointing at 4, so that's gonna be like that. Okay. Mm-hmm.
Now what do you do?
Now we increment the count again. Mm-hmm. Increment the count, and also move over your pointer. This is even in this case. We add it to list head 1. We point the .next value to 5 or 5. Mm-hmm. Increment the counter. Move over. Okay, so now we see that it's excuse me. So now we see that it's odd. So we add it to the beginning of list head 2. Mm-hmm. We add 6. Mm-hmm. Increment the counter. once again, so your out of bounds, point it to the next, which is null. For this case,
Okay.
there's
So you're okay. Perfect. See, this is what I'm trying to really get you to do. I'm really trying not to get you to skip these steps. You saw how you had the tendency of like, oh, I don't need to skip the count. I don't need to add a counter. No. Like each one of these moving pieces is really, really important to your algorithm because you know it's exactly what you're going to be doing in the code. And if you start skipping steps in the planning, you're going to start skipping steps when actually writing it. Now that you have that, look at your lists. What is the problem here?
There's not. They're not the end of list head 1 is not pointing to the beginning of list head 2.
Okay. Do you have another problem? What happens after this?
I didn't save the tail in this case.
Well, you have this dangling tail now. Because if we link the end of list head 1 to the front of list head 2, you have 6, 4, 2, and node. So now you have this node here, and you have this node here. What are you gonna do?
We want to advance list head 1, point it to the 1 in this case.
Okay.
But there's no way to go back, so I'm kind of stuck. I have to think of something else here because here where it says 2 node, I just have it dangling there. There's no way to go back.
Right.
Because it's one directional.
Correct. Why are you in this situation to begin with?
Because I didn't take into consideration the tail here.
Okay. Yeah.
I didn't take into consideration the step where you actually link the 2 lists here.
Okay, sure. So you didn't take into consideration of it. What in this code, what was the very first thing that made this node appear then?
That's before we did all our steps, we defined it ourselves.
Yeah, we did it here. We fucked ourselves over here. If this was null, then what happens is you have this. Literally, this because of this step that you didn't really think out, you fucked the rest of the problem.
Yeah.
So, this is what I mean. Like, you need to also be able to backtrack and think about the first step that happened. Because if I replace this node with null, then your problem goes away.
Right.
And all you need to do is just figure out the head of wherever the hell this is. And then boom, this would be your solution. So, knowing that now, can you actually do the problem?
Let me see. Okay. So I have list head 1. List head 1. Okay, so yeah. So what? Okay, so at the end, since we already took care of the list head 2 equals null at the end, you can just do list head 1 dot next equals list head 2, and that links both the linked lists.
Okay.
Yeah. Cool. Okay, so I have list head 1 equals node. List head 1 equals head. So now iterate over the list, maintain the counter. Okay. So let's do this now.
Okay. So just like you did it, how do you want to do it?
Okay, I'm gonna base it off this example and design we did here. So basically, follow every step there. So we have to maintain the counter. Counter equals 0. Iterate over the list. counter to get alternate nodes. So I'm just gonna move this to the top because we
Sure.
talked about it already.
Sure. Whatever helps you.
Yeah.
And then you don't need, and since you did that, you don't need this. You don't need this. So, okay, go ahead.
Okay, so even. Okay, so let's say is it? We're checking if it's even. Fuck. What is the divisible by 2? Okay, so if that's the, oh man, went over the next page. Anyways,
Whatever.
yeah. Okay, so if that's the case, add it to list head 1. So list head 1 dot next equals cur.
Okay.
Else add it to
Are you
list
missing a
head.
step? Hold up. Finish this off first. Are you missing a step here?
Yes. List head 1. I didn't advance the list head 1.
Mm-hmm.
List head 1
Don't worry about the capitalization. I don't care about it.
goes. Wait. List head what? Okay, so this is I have to be careful with this step because I don't want to point it to list head 2. So list head 1 dot next. Okay, it's curved. Let me see. Okay. Point it. Wait a minute. Okay, yeah, that's right. So based on your example, list head 1, it was just the placeholder. You point it to current. List head 1 now equals current.
Okay.
So now what do we do for the next step?
Mm-hmm.
So for the next step, it's R. So list head 2 dot next equals cur.
Are you sure?
Or wait.
What did you say you were going to do for the second list again?
Oh, no. For the second list, you can't do dot next. You have to add it to the beginning of the list here.
Okay.
So for that, let me see. Okay. Oh.
So how do you append a node to the beginning of another node?
You have to you're gonna have these set the head to current, and then the current you're gonna have to point it to what it was pointing to before.
Okay.
So let's head to wait a minute. Let's head to curve. To next. Wait a minute. No. Let me see. Hold on.
Remember, I'm going to press pause here. Remember what we talked about. When you're stuck, what do?
Look back at the example or our
draw it
examples.
out.
Yeah.
Draw it out.
All right. So you want to add B to the beginning of A. Okay, so current. So you want to. Okay. So A. Let's say in this example, current is A, but list head 2 has to be the head now. So let me see. List head 2. Current.next.
What's your list head to right now?
My list head 2 right now. Right now, it's not set to anything.
So let's set it here. Okay, so how do you... And your end goal is to figure out how to get a... This is how you're going to do it. How are you going to do this?
Okay, yeah. Set list head 2 equals current, and then list head 2 dot next equals previous.
What?
Wait. Okay, so in this case, you want to point current to list head 2.
Okay, so current's going to be pointing to list head 2. You mean current.next
then,
or current?
Current.next.
Okay.
So you do current.next equals list head 2.
Okay.
And then you move over list head 2 to the beginning. You said list head 2 equals to current.
Okay, write out what that interaction looks like.
Okay, so...
And you say move list head 2 to the beginning. What do you mean? Do you mean... What? Show me what you mean with this.
You're going to have it here. Let me see. It's going to be here now.
Okay, perfect.
Uh-huh.
Fine.
List head. Wait a minute.
What was the first thing you said?
Huh?
What was the first thing you said?
Let's head to wait, it's because I got this one confused here. Current.next equals let's head 2.
Okay.
Current.next equals let's head 2.
Mm-hmm.
And then let's head 2 equals current.
Okay.
Uh-huh.
Not that hard, right?
No.
Just had to repeat what you did. Now, there is a bug. Do you know what that is?
Yeah.
What happens if I had C, D, E after the A? What you did was orphan these poor little list items. They have no parent now. You made them orphans.
Yeah.
So how do you fix this?
Yeah. So for that, let's call a temp node variable.
Okay. What is temp?
Current equals .next.
Okay. And how does that correspond to what you have in the diagram? I want you to write out where's temp.
Okay. Temp is here.
Okay, cool. So temp is right there. All right. So let's start with a clean slate. So I'm going to put this here, and I'm going to put LH2 here, right? So let's start. We're back at a clean slate here, right? So this is your temp. What happens now? Let's say that this is happening. This next step. What happens at this step?
We're gonna point to list head 2.
Okay.
And then remove this one here.
Great.
And then list head 2 is gonna get bumped up to here.
Perfect. And then, okay. So you now managed to put what's it called B. You put A here. Fine. Now what do you want to do? Is that it?
List head 2 .next equals cur. Oh no! I have to point it to B now. Wait. No, sorry.
You pointed to B.
I pointed it to B. List head 2 equals A now.
Mm-hmm.
So now for the next step. 2. Let me see. Okay, so
Where do you want your cur to point?
I'm sorry.
Where do you want your cur to point?
Cur has to go to temp now.
Okay.
because on your next iteration, you have to advance the list and continue processing the nodes.
Okay. Well, yeah, but then you have this dangling thing. So how do you fix that?
Which one in temp?
I'm underlining it right now. Well, because what you
Oh.
just did is now that you put
Oh.
cur here, remember, draw it out. Once you put cur here, and you do cur.next, now you just skipped the C node.
I see.
What needs to happen?
Okay. Next. Let me see. So the set was at B before, and then we moved it over to A. We moved over current and temp to C to the next pointer.
Okay.
Okay. Yeah, so it's gonna leave C behind if we do this case. So I have to take into consideration to not skip that for this case.
What's
for this
your
scenario.
other option?
My other option is to just leave cur as is, and then if counter modulus 2.
Okay, I'm gonna make it very easy for you. Why not just move this up here? Why not do this?
Yeah. All right.
No. I don't want you to say yeah, hand wave it. I want to know why this didn't occur to you. Cause you're paying me to coach you and fix your mistakes. I want to know why this did not occur to you.
Yeah, that's a step I missed in the while I was coding this up here, because I didn't draw it out, and once we did, that's when you brought it up. But yeah, it's something I missed here.
Yeah, you missed it on drawing it out, and I think you should, if you were if you thought a little bit more about it, I think you would have come up with this, or maybe not. I think you're trying to go for the overcomplicated solution. The simple solution is just like, oh, we've already proven that this works for this case. Correct. So then just keep it in that case. Because at this point, we are already advanced the pointer here, the cur pointer, to the next element that we want to look at. That condition's already satisfied. This last head 2 should actually be pointing to, so this is fine. So you now have a and B situation now. So you got everything you wanted. And then now you need to make it counter plus plus, because per our last rule.
Correct.
And then at the end you would have joined it. So the reason why go ahead.
No, correct. And at the end we would just do the listed 1 pointed to listed 2.
So last 5 minutes, I want to recap everything that we did, and I want to give you some homework because you definitely need it. The first thing that we went over was this problem of the partial red tape, blue tape. Now, the reason why you struggled with this is because you try to do everything all at once. Do not do this. Do not do everything all at once. Advance the conversation. So I'm going to write this down for you. 1. Do not do everything all at once. No magic bullets. Draw everything out and make a simple to complex argument. Every single step that we did here was just draw it out, come up with some rules, and then advance it and make it a little bit, and then go to the next idea. That's all we did here in order to come up with the optimal solution. So here, remember how I said we just check to see if red and blue tapes are overlapping? Then we're able to say, hey, well, if they overlap, then we got to chop off some tape, right?
Right.
So we figured out how much tape we want to chop off. Now the next step after that is, okay, well, now that I've chopped off the tape, I'm going to go into the next blue tape and chop off red tape and keep going and going and going. So notice how at each step, we just drew it out and we said what the result was and came up with rules for it. So when in doubt, draw it out. I guess that's the mantra you're going to do it. So 2. When in doubt, draw it out. That's exactly what we did here. Do not do things in your head. I can't stress this enough because there's a lot of times that bit you in the ass that you basically did it all in your head. Now, this exercise that we did here with the linked list, we basically said, hey, you need to mark what your variables are. Do not skip these steps. So you basically said, hey, I do the counter, I advance the pointer, but a lot of times you skip the counter step. Don't skip it. Don't skip steps when writing these steps out. Record the variable values and check and keep notes, a side note of the order of operations. So that's what needs to happen. Of course, there's all these little things like, oh yeah, well, you have this null at the end of list head 2, and when before you had the node. Why did you get in that situation? Because you jumped the gun and put a node at the end of list head 2, and then we fixed it just by simply replacing that node with null. So that's it from me. There is a lot of fundamental things that need to change, but this is your homework. Hopefully you found all this really useful. Do you have any questions?
Yeah, it was definitely useful. So as far I guess just do more problems. That's and because recently I started looking at the steps you have on your doc and your YouTube videos, where you say match it to a pre-existing pattern or algorithm, then to draw examples. So I guess for my next step is now tackle more problems and just follow these steps that you have highlighted here and what you have in your Google Doc.
The thing is that you've only read half of it. There's another section underneath. What happens when these patterns fail?
Exactly.
That's the part you need to be able to do. Like, anyone can throw a pattern at a problem, call it a day. But more often than not, and this is what I've seen, at least as a trend, that people and companies are asking like these variation questions where they can be open-ended. So, for instance, the red tape problem. If I could expand the problem and just turn it into a streaming problem instead of just a finite list, what if I added more red tapes? What if you didn't have the red tapes to begin with and I made it like, okay, you're going to receive a stream of red tapes instead? This is basically the type of questions you're going to be asked, and it's very important that you be able to break down the problem step by step and be able to do operations like these. Now, the best people who do these aren't waving some magic wand. Like the people who pass these these coding interviews. They're not like YOLOing some random ass thing out of nowhere. They're just doing these steps very, very fast. That's it. They just do these exact steps very fast and can do it in their heads to some degree because, one, they've seen problems like this before, so they know what to expect, and two, they know how to reverse a linked list in their head because they know the steps, But overall, the step-by-step is exactly what people do. There's no magic to it. It's literally just, I give you the raw mechanics. All you have to do is just get fast and really, really good at it. So it's not about doing a lot of problems. It's about doing these problems right.
Okay.
Does that make sense?
Yeah, that makes sense.
Perfect. Any questions?
No, that's pretty good. I'll definitely I'll do some more problems and look at this suggestion you have here.
Yeah, and since this was live streamed, you can actually watch the coaching replay there as well. I definitely recommend that you hit up people in the Discord if you're not joined on it. There are a lot of people there who are very interested in also becoming really good at the technical interview as well. So definitely will help if you're looking for study buddies or some tips. Yeah, and let me know how things go.
Cool. Awesome, man.
All right. Yeah, I'm glad you found a lot of value out of this, and hopefully you improve, and let me know how everything happens. Okay?
Okay, cool. Thank you.
All right, for sure. Take care, man.
All right. Thanks. You too. Bye.
All right. Okay, so then the rest of you guys, let's see what you guys came up with for the tape problem. I'm still gonna catch up on this stuff. So if you guys came up with a solution and want me to show it, I'll show it, but put it in the Discord or at least link me to a paste bin. So let's actually do this. Yeah, you can reverse as you go along. It's a matter of you append to head or tail. Yeah, that's correct. So what a lot of people end up doing is that they try doing some two-pass algorithm like what he did, or they try doing like a stack and then iterate through that stack again, which is no better than two-pass either way. And so what I was really trying to focus on here was this logic, this ability to understand what you're doing and understand the limitations of it. So in this case, to reiterate, there's a two-pass algorithm, but he did the pass in the first. He iterated over the list in the first step, and then reversed the list in the second step. So that's basically, and the logic was, okay, how do I combine these into one step? And then boom, that's how we got it. So I'm gonna look at the Discord, see what you guys posted in there, and let's see what's up. So, okay. So work from home. I'm going to put the Discord up on the screen here. Hopefully you guys don't mind. Let's see. Okay, nice. Everyone put spoilers up. Merge all the red tapes together, merge all the blue tapes together. Okay, that's a pre-optimization, sure. Set pointer on red, set pointer on blue. Okay, if red start greater than blue start, and red and less than blue, and return false. Okay, I'm assuming that means that you are going increment red pointer increment. Well, here's the thing. What if this blue tape was in between? So let's say in this 3 to 6, what if I gave you a 4 to 5 and then made this one, something else? Then you have to start splitting up your red tape, and I don't think you considered that case. In that case, you would need to put back in the red tapes. And that is kind of that's kind of, I think, the thought process that you missed. If we go back to the example I gave back here, notice here how in example number 5, if this situation occurs, I need to produce more red tapes. So that's why this solution is incorrect. It doesn't take into account of that. Next one, Python. Okay, whatever. Merge interval pattern. It's not really a merge interval pattern, actually. There's not really a good pattern to this one. I think merge interval does play a part here. And if you are familiar with heaps, this does help. For instance, merge all reds and blues. Having this putting these in a heap and sorting them by the first open interval and end, you actually do get some runtime improvement on this. Current problem on the stream: if you put a fast pointer and a slow pointer, you can swap bottom and fast to get the last node and continue swapping until the fast meets. Okay, so let's see what you mean by this. 1, 2, 3, 4, 5, 6. 1, 3. Okay, so you swap this 2, 4. Okay, so you swap 1, 3. Oh, this is clever. This is clever. I like this. Let me double check this. So okay, so you swap 3 and 2, and then you double advance the pointers. I think that's what you're trying to do. So you swap the pointers, and then you have your leading pointer go over to 5. Okay. So then you swap and then go over to 5. Okay, I would like to see the code for this, actually. I think this is actually this is interesting, very nuanced, and I definitely appreciate this one. This is not something I would have obviously thought about. I'm not sure if you do a double advance or a single advance on this one, and whether or not you pin to the end. But if you have some code and you can throw it into a leak code submission, show it to me, man. I'd love to see this. Trust me, a lot can happen in 2 hours, and not a lot can happen in 2 hours. It's not even that bad, to be honest. He did most of the talking, and I'm mostly just trying to drill him to do good habits. Because really, the way I structure a lot of these coaching sessions is the first hour is really just for me to scope out what his main problems are and to really start breaking down his bad habits. And the second hour, I usually just focus on like 1 or 2. And then try to get them to practice it, get them to start breaking those bad habits. And then ultimately after that, once they know what to do, I give them the homework, and it's up to them to whether or not they want to implement it or not, because I can't help people who don't want to do the practice. I can tell you what to do, but, it's like the old saying, I can lead a horse to water, but I can't make it drink. So log ends. Is this solution better than the 2-pass ON? Yeah, this is 1 pass, correct. And you don't have a lot of temp variables that you need to manage. That's true. And realistically speaking, when you have these temp variables, these are just like, memory references. I'd have to write it out, but I think you actually do exactly the same thing. You might end up with a little bit faster, or no, I don't think you do. No, yeah, you do. Yeah. I end up with like all these temporary variables. But, it's memory. These are memory references. So if you can come up with a pretty good algorithm for this, I'd love to see the leak code performance on this. 1 pass open. He wanted 2 pass to 1 pass faster optimization. Correct. Work from home. Let's see what you got. Reverse odd and append. Remove next node. Always be node. Insert the node and head front. Temp next. Net. Okay. Yeah. I think this is basically. Yep. This is basically what we got on stream. Cur.next. I personally don't like the cur.next just because there's like a lot of ways that you can mess yourself up. I understand what you're doing here. I don't mind it. But personally, I go with the dummy head most of the time. It's not as memory efficient, but it does keep this cleaner because once it's more like a confusion with human design. I'm not gonna say your answer is wrong actually, because also wait, this is wrong because if cur.next then cur.next.next, shouldn't this just be cur.next.next is not null because you're already looking at cur.next. So this should be cur.next.next instead, right? Or am I just being stupid here? I don't know what the leak code number is, but I think if you here, how about this? I will post the exact text in the chat, and if you want to submit it on the Discord, let me know. But I think there might be a small bug in here. From I work from home. Again, it's this whole cur.next confusion here. Okay, let's see what Mohi CS says. Okay, sure. Ad block. No, I have ad block for a reason. I need to watch my anime, dude. Edge case. Okay. All right. Sure. Oh, I like this. Okay. Reverse alternate. No, let's see. So step 1, init 2 head with a head and then first head, first tail. Sure. Okay, first head. Well. Okay. Odd equals head. Even out next. Okay. First. Honestly, it's just too verbose. This one's just too verbose, dude. I don't know if it's right or not. I mean, it looks okay. The reason it just boils down to the fact that you have so many variables that are unnecessary. If I were to do it this way, what I would do is I would just have a pointer that says head like odd, and then have an internal variable even here, and then just check to see if odd.next is null or whatever. It's just that there's so many moving parts to this that I don't really want to check it. It's too overly verbose. Things need to be streamlined and very easy to read. That's my feedback to you. But again, if I were you, I would try testing this with an odd number of nodes. So what happens if I were to chunk this away? This is a Windows computer, so I don't have IntelliJ set up on this. But show me what the output is if you took away this 6 here. Also, what would happen if I passed in if I passed a null, then you're going to check it, so I think that's fine. And what happens in a... Yeah, I think that's basically it, actually. I mean, I guess LeetCode could throw you something tricky, like what happens if the linked list is circular? That'd be interesting to see. It's not on LeetCode, huh? Let's do some diving. All right, LeetCode alternate linked list. Even odd linked list. Given the head. Oh, I think this is it. Given the head, regroup all. No, this one doesn't reverse it. This one doesn't reverse it. These are the solutions, but 5, 4, 3, 2, 1. This is okay. Easy. Reverse the linked list. Okay. K group. Yeah. Alternate K nodes. Whatever. To be honest, I am lazy as fuck. I don't want to find the problem, but if you can write like a test case like this way Moisius did, I think that'd be good enough for me. There's a similar version on binary search, except the second list is not reversed. Yeah. I think the fact that I reverse it and ask you to append it to the end, is really just more of a, it's more of an optimization on top of an already existing problem. And for the most part, I actually don't think. Yeah. This lead code wouldn't probably have it. I think it's just the fact that it's a little bit nuanced and requires you to think a little bit more outside the box than what lead code would have you think. So, anyway, so for people who are really interested in how I would advance the tape problem, now this is going to be a very interesting problem because a lot of these actually have real world consequences. So, let me properly explain this. So, red blue tape problem. Let me actually bring up the let me copy paste the problem statement for you guys. So, right now the basic problem is red blue tape. So the question here we're going to answer is, what the hell is going to happen if, let's say, I came across a candidate who, managed to pass the first part with flying colors? Well, then the first question is, how does your algorithm change if I introduce a bunch of red tapes? And that's the optimizations that we were talking about before, merging in a lot of these blue tapes and red tapes that were occurring. But of course, the optimal algorithm, as you saw from example number 5 and case scenario number 5, is that your algorithm should already be handling this. So essentially, this would force you, and if you didn't, you would be forced into a queue of red tapes that continually check that are continually checked by blue tapes, and then your queue might actually be a heap sorted by the front, because then you could also do an optimization where if we're past the limits of the tapes, then move to the next one. And so, or instead of a heap, we could do a sorted list. So then this eventually becomes a two-pointer problem of intervals. That's it. And then when you go ahead and break apart the red tape, you just replace that one tape with two tapes, and then continue on. That's essentially what happens here. It becomes you can actually turn this into a two-pointer problem instead of a merge interval problem, and then at that point you actually can get an order and solution and you could do this actually in one pass. If you're good at it. And so the next part would actually be, what happens if I gave you a stream of red tapes? And so how does that change your problem? Well, it doesn't necessarily change your problem that much, because at this point you're basically just going to have a sequence of these problems. Except that the red tape at each time is just going to change. But you do end up storing a queue of tapes, because then what happens about a stream of blue tapes as well? Because these blue tapes can actually affect the sequence as well each time. So then all that would change is the low-hanging fruit would be to add these to the queue and then rerun the algorithm. The optimal way of doing this is just to rerun the algorithm on a subset of red and blue tapes. And that would basically get you to where you want to go. Now, what happens if I introduce, let's say, buffering? That is, instead of me sending down these tapes one by one, what if I allowed you to group these tapes and batch the processes? Now, how the heck would you actually be able to do this? Again, the algorithm doesn't really change too much, and especially if you have an optimal one, for sure. And so because of that, what you would do is you would just end up merging the tapes beforehand, and then submitting them in sorted order. That's really it, and that's basically what would happen here. So hopefully you guys had fun with that. Let me know if you guys have any questions. Put it in the chat or. So hopefully you guys had fun with that. If there are no more questions, I'll stop the stream, but let's see what you got. We can talk about anything. It doesn't have to be this. What's it called? It doesn't have to be anything regarding interviews. It can be career. It can be whatever you want. This is like kind of a chill time. Yeah. I will say that this is not as mean of a problem as I'm used to giving. For instance, a really mean problem would be, suppose I gave you let's say play race, right? A bunch of numbers, right? Give me an algorithm that creates two groups of 5 numbers such that the average is as close as possible. Now, this is a fun one for anyone who really wants to do this. Oh, not like if you guys really want to do this one has real world implications. So, for instance, if you want to design a matchmaking algorithm for like League of Legends or Dota or whatever, this is a real problem that you want to do because eventually what ends up happening is that you're going to have create two groups of 5 numbers, but then we're going to have n groups of 2 groups. And then you want to be able to efficiently do this. Because, in the real world, what you're going to have is like a player base of like 1 million numbers, 1M numbers floating around. And then out of that, I want you to create 2 groups of 5 numbers. And if you don't use them, then maybe you can, try to create another group of 5 numbers. And then what happens after that? Well, what happens if these numbers don't exist after creating them? Like, for instance, what if a player leaves the queue, or he leaves that pool? Then what's your fallback algorithm? And this gets into a really, really interesting part of system design, where you basically have a non-deterministic system, where once you've created the answer may no longer be valid. It's like the Schrodinger. Is it Schrodinger? It's like, well, the moment you observe it, it's like you change the state. It's like the Schrodinger cat problem. So Ricky says they asked me a given set of number groups with a number of 2 sets. Oh my god, okay. That was my question. That was actually my question. I don't know who stole that from me, but that was mine. It is a dynamic programming problem. Dude, I don't know who did it, but I remember the first time I suggested that. That's actually, they literally told me that that was too hard, and that was only a question you want to ask if you want to torture someone. So, yeah, you're right, Ricky. That is a dynamic programming problem. You want to do a priority queue with some people that have been in a queue for a while, right? Yeah. This is where we start getting into a little bit more of like the high priority, low priority weights. How do you want to handle that? Do you want to add to their number? Like, and then again, what ends up happening is that, or do you want to, change the average to a range, et cetera. This is beyond the problem, though. Like, how do you want to optimize your system? This is where we start evolving your code eventually. So what are my exact stats exactly? So I don't want to violate. Oh, sorry, hold up. Give me a sec. Let me actually show you something interesting. So let me open up my student spreadsheet, and let me hide the names for a hot second. Okay, so since you're very keen on looking here, I think I hid all the information, but I keep a full-on list of people who coach with me. Their what their goal is, internship, what company they're going for, like what notes they did in the coaching, and then like where they got offers from. So to answer your question, Moby, this is basically what I do. Like for instance, this student here did some various interviews. Some people here did are freshmen. I record the dates, how many sessions they did. Of course, I'm blacking out all this personal information here as well. But basically, my numbers end up being somewhere around 75%. So you're listening to people who have consistent results stats versus someone who has one internship or one full-time family. What are my stats? So so if you look at my guide, I write that my stats are 4 out of 5, so 80% for the last round, and I got L3, 2 L4s, and 1 L5 offer. And yeah, I did. And for the phone screens, I think I am 90%. Yeah, I think I'm 90% for phone screens. I botched Twitch, actually, because. Well, for one, I'm doing, 10 phone screens in a month. And holy shit, do not do that, guys. Do not do more than 2 phone screens a week, even. And I was just really forcing myself to do it. And then okay, funny story time. So basically, when I was doing the Twitch interview, I was in my Apple office. Almost always, I would have gone back home and done it. Instead, I was really stupid and forgot about the interview time. And because of that, I literally ended up doing the Twitch interview while I was at Apple, literally in my fucking office. And that's probably why I tilted out, actually. Okay, so definitely, that sounds like a program grokking. I fucking hate you. Hi. Have me start with a brute force solution, even though I knew it was a DP problem. Yeah. The thing is that I will make you do, that's what every single person will do. You start with a naive solution, the naive brute force solution, and then you go to an optimal one. And so that's the thing. You need to be able to prove that the question goes from a naive to a dynamic programming one. And no one's going to say you, hey, just start on the optimal one. You need to provide the correct reasoning here. And that's exactly what we emphasized today in his coaching session, that we started to make this argument. Now, draw it out, say it with logic, and then show where it's going to go in order to get the optimal solution. And the same thing is going to be for that dynamic programming problem, Ricky, that the problem that you're given, you need to say what your naive solution is. Just say it and say, hey, this is why this is not efficient. And say, okay, using this insight, you can go to a more optimal solution. So for instance, for a lot of the dynamic programming problems, it's really just a composition of recursion, a tree state, and then memoization, which is being able to reuse those states. Now, once you have that, then you can essentially say along this dimension or along this optimization, then this is where you start, looking back at these number of arrays. And based on that, then this will build your bottom up or top down approach for dynamic programming. And if you just said that, I think most people would have just understood, hey, you understand dynamic programming at a really good level. So I think that's probably the part you missed. So my personal stats are like 80 plus or so. I need to double check that. And then my student stats are like 75 ish. Yeah, I would say 75 for across every single interview. If you ask me how many have received at least one offer, I think the number bumps up to like 85, 90. Yeah. So, and as you saw on that sheet, a lot of people basically had like had a lot of interviews going on. Some people, like I think this guy, yeah. So he had Facebook, Microsoft, Amazon, and then he he botched Facebook because of personal issues. I don't want to go into them to not violate his privacy, but then Amazon just didn't get a call back. Microsoft, he got a offer. And then let's see, on-site interview the 19th for this guy. And then looks like he passed that. And then failed Google's made higher committing at G. Let's see. Yeah. So the reason why I know a lot of mistakes that people make is because I see a lot of these same mistakes here. Like, and the most interesting, for instance, like for him, don't do things in his own head. Magic wand, weak on time space analysis. 2 weeks out from the interview. Literally, this guy is literally in the exact same spot as the guy today is. He still managed to get to Amazon, and he made the hiring committee at Google. So I'm very, very confident in my ability to turn what the guy you saw today, and I know a lot of people were like making fun of him in the chat and whatever. Dude, that's a whole. Don't do that. That's not cool. But I literally turned that guy from not being from what you saw today to getting an offer from Amazon and making hiring committee at Google. The results speak for themselves, dude. So, how do you get that? What's my day-to-day? My day-to-day basically is I wake up at around like 9-ish, 9 to 5 really. And then after that, or 5:30 really. And then after that, I go to the gym, come back 7:30, eat something. And then from 8 to midnight, a lot of it is up in the air. Sometimes I'll do coaching sessions like these. Other times I will literally just spend the whole night playing Dota. But recently it's been mostly like a third of the time I'll be doing personal projects or coaching here. A third of the time I'll be playing Dota, and a third of the time I'll literally just be reading blogs. Of course, I'll mix in the time in between, but essentially you can think of it as in a given week I'll play like 16 to 20 hours of Dota. and bump that up on the weekends to maybe 25 to 30. So, and then like putting personal projects, I don't know if some of you have seen it, but I have a valuation bot. That was basically a personal project. Here, let me boot it up on my computer, and I can demo it for you guys. It's actually kind of interesting here. And I'll do a video on how I actually built this, but let's actually say, let's go here, right? So let's have a valuation. So let's do a valuation of a company, right? A value bot, Apple. So what's gonna do? It's gonna hit my computer, if it will start up, and then it will do an actual valuation of the company. It'll show all the math. It'll submit the math as well. And again, these are really good projects if you want to do if you're looking for projects to do as a student and you're not sure how to get your foot in the door. And so for instance here, if you look at the, I can't really zoom this in, can I? Let me see if I can zoom it in. Yeah, I guess it'll do. So yeah, you can see like I print out all the expected rate of returns, the valuations, the predicted growth rates, free cash flow models, and this is like some of the personal projects I like to do, just because it's it's really interesting practice in Python, just keeps my mind sharp, and I like exploring a bunch of different things. But yeah, if you can come up with this, I think you have a pretty good solid understanding of the fundamentals of computer programming. You can probably do things at an L3 level, and again, the history of this bot is something I want to do an actual video on, because a lot of how this bot was developed is very much how we develop things back at like Apple, Google, where we start we start off with a very basic proof of concept, and then we evolve that into an actual product. And of course, along the way, because we don't fully understand a lot of what we write sometimes, we slowly start refactoring towards a much cleaner architecture. And so this bot is essentially an exercise in just that. And so I think it's really useful. It would be really useful for you guys to really understand how these go. And so, yeah, just look forward to that. So that's basically what part of my time is spent doing. Just doing random projects like this. So I'm going to put the bot away. Again, this is not telling you to actually go invest in Apple. This is literally just a bot project I just wanted to show you. So I'm not responsible for whatever mistakes you might make. If you decide to long GME and YOLO your life savings into call options, don't blame me. I did not encourage this shit. Interview horror stories. As the interviewer or interviewee. Oh my god. Okay. This is interesting. So you'd be very surprised once you get into industry how many people don't actually care about programming. What do I mean by this? A lot of people are in the job to, just do the job and get paid and move on with their life. And they're just there to collect a paycheck. So what ends up happening? Oh, sorry, my mic cut out. So what ends up happening is that a lot of these quote-unquote senior engineers, they don't do very much coding themselves. And at some companies, they consider that as a good thing, because then you're delegating these coding every day-to-day tasks to to other engineers. But at the same time, that rusts your ability to actually write code. And so what you end up doing is you just think like an engineer who's living in some kind of fairy tale land, never actually having to figure out how to write code yourself. And in my opinion, if you are not at least writing some code, like you'll never see a staff engineer not write code. They might not write code day to day, but they will at least come up with proof of concepts and test drive a project before they even put it out there. And so we had this one time at Apple. We literally had a senior engineer apply from like some random company. And I don't want to disclose the name. And he basically went up to and whenever we gave him a question, he went up to the whiteboard, would start writing something that looks like code, and then eventually he would try to like talk it out, like hand wave. It's like, oh yeah, but if I was going to do this, I do this. Like all these random optimizations. And like they all sounded really, really, really good. But then 10 minutes later, we realized that this guy was not even writing code. He was just talking about it. And we literally just told him, hey, you want to write one of them for us? And then literally he would just like try writing something and then just continue the talk. I think that was the most funniest one that I have ever had the misfortune of ever being in. And literally once we went to like hiring committee and started talking about it, we literally all just said, hey, this guy is a really good talker, but he doesn't know how to code. He literally tried bullshitting his way through us. So that's a really good lesson. Do not bullshit the interviewer. We will pick up on this. You have 40 minutes to try and bullshit us the entire time. Don't do it. We're gonna catch on in like anywhere from 5 to 10. So that was the worst one, actually. Holy shit. Like, people, like, this is one of the things I'm really trying to emphasize to you guys. Care about your career. Care about writing code. Because if you can just do this for like 2-3 years, you will surpass people who have been doing this in the industry for 10-15 years and have not cared at all. Like, it doesn't take that long for you to become really, really proficient if you are very deliberate in your efforts. Control plus on Discord to Zoom. Okay, nice. So Devin actually finished up I'm very interested, Devin. Let's see what you got. Did you post it to Zoom, dude? Or did you post it to Discord? Lead code question request. Is that you? Okay. Is it in the off topic? Rip. Yeah, rip DMX. It is not financial advice, guys. Like, you can read books on this. You can write your own bot. There's bots on Discord, not Discord, but GitHub as well. You can actually write these yourself. It's not that difficult. The difficult part is actually the instinct. I mean, I have Thinkorswim downloaded here. I'm not gonna show you guys my account, but yeah, like, this is something I like to do, well, at least in the morning before work. Sometimes I'll be lucky enough to have enough energy to wake up at 6-7 a.m., trade markets for a little bit before work. But that's it. Previous company had a lot of people collecting paychecks and decided to move on to Fang just because of that. Yeah, they were collecting paychecks, didn't give a shit. But the thing is that we can tell a bullshitter, like, really, really quickly. And I would bet, Moby, that they didn't even make it. They didn't even make it to Fang. Definitely want another interview horror story. First one was good. I don't know. Like, a lot of these horror stories are mostly just people trying to, how do I describe this? Like, a lot of the horror stories are not kids who are straight out of school, believe it or not. Like, for all the people who are really, really afraid of messing up on the interview and, like, afraid of looking like an ass, our screening process does a very good job of weeding them out before you even hit the on-site. Literally, I don't even remember people I talked to for phone screens. Don't worry, you're, like, wiped from my memory. But the people who try to, like, lie to me on actual on-sites or, like, do shit like that, I never forget, man. So I'd rather not. Let's save the horror stories for another day. One corner case you're trying to solve. Okay. Let's see. Yeah, I would say you try to do it on a little bit longer list. Because, again, your solution looks a little bit complicated. It looks okay with 6 items, but try it with, like, 9, 10, see how it goes, and write out each step. That's my suggestion. But, again, I don't think this problem is worth doing a lot because, again, there's a very simple problem, and we just really like simple answers. We don't need something super crazy and creative because oftentimes, if you submit this in actual production code, we will not be able to understand it. We will not understand the logic behind it. We will not understand the intuition. And chances are we're going to refactor it. So very often, this would not count. So it's not worth pursuing. But again, if you manage to come up with the right solution, more power to you. Can you tell us the story of an interview you struggled on and failed, a recent one, when you were following your current strategy? Good one. Yeah, that's a really good answer. So a little history about my strategy and the way I approach things and the doc. Basically, this doc was born out of like a few years of effort. The first time was me coming straight out of school, and I didn't really understand what I was doing. Like I just thought very much along the same lines as you guys did, who we basically thought it was just like passing the leak code interview, but turns out it's like so much more. It's your ability to logically represent a problem and be able to build on it. A lot of it is just really just being able to present some clean, cohesive logic and be able to break down a problem like that. And I think that having struggled with that before, that was really, really a big kick in the pants. Fortunately, I got into Apple, so I didn't have to worry about that for a while. But then once it came out again, I thought the second time was so much easier because, again, I gained this intuition after working in industry. I understood how to, yeah, odd number of elements. I kind of figured. So, what basically happened was that I was like messing up for a month before I could even figure out what the hell was going on. And the way I figured this out was basically I was like doing leak code problems. I wasn't getting anywhere. And it's very much the same way I think about Dota, think about my own engineering efforts. So I just restarted the effort from the beginning and said, okay, what do I have to do to get predictable results and consistent results? And once I had that, that gave me the motivation to really do things. So to answer your question, a story of when I really struggled and failed. I think this was probably my Yelp interview, actually, when I was first starting out. And I think I got most of the problems right. Like, for instance, I remember, like, how would you go back in time to find a problem with a Git commit, you know? Of course, there was he represented this as a linked list, you know, or an array. And then I said, oh, yeah, I would just do, like, a binary search on it. And if I overstepped it, I would just backtrack and then just, like, take a little bit less of a half step. But I think what should have been the right solutions to questions like that was the limitations and patterns not patterns, but the limitations to the problem I was doing. And had I actually spent the time to really struggle to just not struggle, I should say, really explain down to the nitty-gritty details, be able to do what I told the guy today to do, be able to break down a problem and just do it from the ground up. I think that would have helped. Of course, the Apple story, I've already done a video on, but the overall struggle, I think, was just, being able to explain things at a very basic level. And I think that part was just really lacking in me for a lot of the very early interviews I did. That's not really an interesting story. That's more like an overall theme, I think. So I'm sorry, BDC. I don't think that answers your question quite yet. But it's really hard for me to really pinpoint a really, really good story for struggling and failing because I don't remember failing an interview. Remember failing a bunch of questions that leads to a failure of an interview. And then each one of those questions, I'm like, oh shit, I should have done this. Oh shit, I should have done this. I don't really have a cohesive narrative to really put together other than the moral of the story, like what I just said, being able to break down a problem at those fundamental levels and explain it very simply. Just use bisect. Yeah. I wasn't really proficient with Git at the time coming out of school. All I really knew was git add, git commit, git push, git init. Of course now, like, git merge, git rebase, git cherry pick, I don't even use bisect, by the way. I just look through the history of whoever fucked up, and then like point to the last commit, and say, hey, yeah, this is the commit that happened. Who the hell did this? All right. So Devin actually came back and said it worked with 5, and I don't know why, so I had to chew on this for a minute. I mean, yeah, you can chew on it, but again, it's like probably not worth the time to spend a lot of effort doing it. So, git blame is what I use. Git bisect when you run options. OP as fuck. I've never actually used it, so I can't speak to it, but I'll take your word for it. Next time I'll use it. But I will say that, like a lot of these toolings, like at Facebook, you'll actually use a variation of Git. It's called Arcanist. And let me actually show you. But basically, the reason why Arcanist, I don't know why it's giving me some Final Fantasy 14 shit. But basically, Arcanist is just like a suite of tools that basically encompasses a lot of Git commands and lints and everything in order to package everything nicely, so you don't have to like run like Gradle build and then git add, git commit, git push, all these fancy shits. So but Arcanus does some really funky stuff under the hood. So, for instance, if you're used to like a GitHub workflow, a lot of what you're going to do for merge requests is based on git merge. And what Arcanus does, for some freaking reason, is actually use git rebase, like in order to try and figure out what the hell is going on. So this, instead of like having to merge stuff and make sure that the merge conflicts are okay, what ends up happening is that you have to make sure that your previous commit is in, and that every single every single commit in between when you created that branch and where it is now does not create a merge conflict in your current branch. Like just because the way rebase works, it's going to try looking through every single commit and then put it on top and then try to make sure that it's okay. So you need to hope that in between this and this, that in between here, your whatever's in here is not like being conflicted in. So that is a drawback to using Arcanus. I have no earthly idea why it does this. I get it makes the git commit so much cleaner, but holy shit, have I not had a shit ton of nightmares using this. Where do I get these questions, or do I get them myself? It's a collection of questions that I have based on my own experiences. These are questions that I remember being asked. Other times I'll look at questions on LeetCode or online. So a lot of these questions are publicly available, or sometimes I'll invent my own. I'm not using anything that is like proprietary or in a test bank to my knowledge. In fact, I don't even do that. And then I tried looking at what variations I can do on this question, what spin can I do, and what would an optimal answer look like. So for instance, whatever I did today, the red blue tape, it's like, okay, well, it's very open-ended. I can not this one. This one is the wrong document. Yeah, so what I did today for the red blue one, there's a lot of different angles I can go with and make in order to bullet test someone's algorithm. And so the optimal way to solve this is to go step by step, to start with the naive solution and build on the top of that in order to get to the optimal one. The reason why I like questions like these is because you can't throw a pattern at it and call it a day. You actually have to prove your answer. So the questions that don't have patterns as an easy way to solve them are my personal favorites. Because, well, one, I like seeing people squirm. Just kidding, I'm not that much of an asshole. But really, a lot of what you see day to day, and a lot of problems in engineering, almost boils down to someone over optimizing. Like 99% of the time, it's people over optimizing random shit they shouldn't be. And the reason why they over optimize is because they don't fundamentally understand the use case that they're aiming at. And if these are not the type of people I really want to be working with, and it's been a habit of mine ever since Apple tends to hire for the team, and this, like, we would hire for our team, and I personally valued someone who didn't do that shit, who didn't like make those big leaps of faith. And so my intuition and my understanding of what makes a good engineer great is this ability to really go through a naive solution and understand the nitty-gritty principles of it, and then be able to build that to an optimal one. And I think it's also that gives it a lot of credence and a lot of flexibility in thinking. That's why my success rate for getting people into these companies is so high, is because once you understand how to really build these solutions from the ground up, you can do whatever the hell you want with them, and go in whatever direction the interviewer wants you to go in. And it doesn't really take that long to get there. And whereas I think a lot of people really try focusing on being able to solve problems, I really don't. I really focus on making sure that you're doing these problems right. I firmly believe that if you're doing this right, it doesn't take more than 100 problems for you to get to a very, very master level and be able to get like really high offers. I think, like for the girl who got the second highest possible Google score, like she spent a few weeks studying, but for the most part, it wasn't as grueling as what most of you did. I think she did like somewhere in the ballpark of 100 as well, or 115, 120. I could be wrong, but essentially, if you're overworking and not getting anywhere, something's wrong. Sounds like Jane Street developing their own proprietary Git merging solution. Honestly, probably, but Arcanus is open source. This is what Bitbucket does. No, I'm pretty sure Bitbucket does a merge. And do it because we've used it before. And I'm pretty sure, I'm almost 90% sure Bitbucket does this. So let's see. Bitbucket, rebase, or merge. Pull request merge strategies. Conflicts happen with merge strategies with conflict. When a conflict occurs, really reply the merge to resolve content locally and attempt to reply the rebase. Okay. So merge strategies is the okay. So it looks like there's a few ways. So it looks like there's optional ways they can use a rebase, but you can also use merge conflict. Here's the thing, rebase is like, it's nice, it keeps your commit history really clean, but the problem is that once you have like a shit ton of commits in it, it's going to be a nightmare. So for instance, let's say I am bug testing something and then I'm constantly deleting a line of code, re-adding it back in and deleting it, and then someone else modifies the exact same space. When I go to rebase, each time I made that delete, I have to resolve that conflict. It's an absolute trash nightmare when you start getting past like 3 to 5 commits. And so that's why I really don't like rebase. It's just not nice. Plus, most of the time, the commits that you're adding are like, git add, git commit message test, or git commit random message just so I can get it to merge into my local branch. So almost always these rebase messages are completely meaningless. So it's like rebase doesn't really help when it comes to the local branches. When it comes to the master branch, I can see it. Yes, I understand why it's there. But when it comes to local branches, there's no reason to use rebase other than to, make it look nice and maybe make it simpler and easier to manage. I mean, that's really it. Also like the one other case is when you have two people working on like the exact same feature, and people are making minor changes. Then you can see, hey, I applied this change because of this, and if you can resolve that and it makes the commit history a lot easier to understand if you can at least contextualize the commit that you did. But again, the whole thing is that a lot of people just do git add, git commit, random message, which kind of defeats the purpose. So that's why, like 9 times out of 10, I'll use git merge over git rebase. So, I haven't done any dynamic programming problems or understand the basic things like top down versus bottom. Would you say I need to practice that before applying? I don't plan on applying to Google yet. If you are doing the interview rounds, you will at least get one problem that's dynamic programming. I can guarantee you that. So it's worth understanding at least. Again, Grokking, the coding interview, has a really good section on dynamic programming, I think. Dynamic programming. Yeah, this is really good. How much does it cost? Here, let me log out. Let me get you guys a price. Get this course for $59. Yeah, $16 a month, guys. Like honestly, if you're looking for like 2-3 years, not 2-3 years, but like if you're practicing for interviews, you're gonna need like only 3 months of this. So you can always like share the course amongst each other if you really want to. Personally, I don't recommend it because personally I really like this course and I would appreciate you guys to donate to them. Again, I'm not shilling out for them. I just really, really like them. I'm not even giving you guys a referral link from me. Like that's how much I believe in this course. I think if you can do this and understand its explanations, you will do very well on these. Yeah, just focusing on graph problems. Yeah, I mean it happens. But yeah, graph problems are pretty standard. I think the trend now is like only to ask like one graph problem throughout the entire interview, just because a lot of it just takes too much time. It's a lot of boilerplate code to set up, like with your adjacency matrices. Okay, 16 a month if you don't want the yearly. Sure. 16, not 60. So, yeah. Okay, so let's see. Let's Dota. Let's go to Dota and see what happens. Predator. Osha. Oh, 729 patch? Wait, what the fuck? There's a new patch? Hold on. Hold on, what the hell just happened? Oh. Water power rune? What is this? Oh. Spawns at the bow. Oh, I see what they did. Okay. So they basically made this so that way no one could get like a DD room at 4 minutes, and then like because like if 2 heroes are level 4 at 4 minutes, and someone gets a DD rune, that whoever didn't get the DD rune is going to be like level 6. It's going to be level 4 forever. And then the guy who got the DD rune is gonna be like level 6 at 6 minutes, and the other dude is gonna be like level 4.5, 5, and then he's gonna get like completely reamed. So this is really to balance the 50-50 rune play. So, and then after 6 minutes, power rune spawn. This is when they can start making ganks. Added to level it up to 7 times, and be leveled in any order. For the 7 empty levels between 126. Okay, so you can actually pick... oh, that's the old thing, where you can actually pick stats instead of talents or skills. Yeah, that used to be a thing where I remember on Juggernaut where people just get like Blade Fury and level 2 stats, because I think back then Healing Ward and ulti and crit was not even that good. I remember that being very, very early, like maybe TI 3 days or something like that. I don't know. Oh, okay, level 30 doesn't give you all talents. 27, 28, 29, 30. I like this one, actually. Gives you the remaining level stats. Outpost no longer gives XP at 10, 20, 30 minutes when controlling. Okay, fine. Now provides XP per minute while controlled. Oh, it's continuous. No extra XP is granted when controlling 2 outposts. So you just have to control 1 outpost for the XP, and then the other time you're just denying the XP. Holy shit. Okay. Bounty runes are set reduced by 10. Okay, fine. I guess that's an alchemist nerf. Bounty runes no longer spawn in the river. Now provided automatically through... okay. Oh, so they just boost everyone's GPM instead of bounty runes. Okay. Bounty runes spawn every 3 minutes in the respective... holy shit. Reduced from 4 to 2. Holy shit. This is actually massive for position 4s. Like, I think it actually nerfs them to a degree, because it forces you to rotate away from ganks, because, like, at 3 minutes, like, oh, the bounty runes spawn, and then, what's it called? The position 4 has to go get it. So this is, like, they can't gank at 3 minutes. They have to literally go run for the bounty rune. So, bounty rune no longer disappear when 1 spawns. They outperform spawn, blah, blah, blah. You know what? I'm more interested in the hero changes. I'll read this later. Fuck it. Shared tangos expire after 40 seconds? The fuck? Are you kidding me? Okay, so then you can't pull mid your tangos anymore. Necronomicon removed, rip. That was busted on Beastmaster, holy shit. Literally everyone's gonna build Necrobook and just like run down towers. Okay. Cooldown, this is still a trash item. No one's gonna pick it up. The stat resist would have been really, really good. Oh, basic dispel is pretty good though. But you need the stat resist, I think. Okay, nerf to Battle Fury. Stun duration. Okay, nerf to Meteor Hammer. Okay, OD kind of got hit. Oh, yeah, thank God you got rid of this. Holy shit, this was bullshit. Okay, looks like someone messaged on Discord. Wind Waker, boosts travel, reducing movement speed. Movement speed meta is no longer a thing. Feels bad. Cast range, no longer a thing. Melee, okay, melee, Mantis Salve, Armlet. Yeah, they really need to buff Armlet. Holy shit. Lifesteal is still trash, I think. Heart. Okay, make it more expensive. Aeondis. I don't think this. Okay, this one BKB is actually more consequential. 9876 instead of the 10887665. I mean, late game it's buffed, but then early game is nerfed. I mean, it's kind of weird because like I think this was because of Alchemist, where you would literally have like a what's it called, a 4-slot Alchemist like Battle Fury, SNY, AC, and BKB at like 20-25 minutes, just run at you with a 10-second BKB and just kill like 2 of your supports instantly. I think that was probably why they did it. What's your advice for getting promoted at Fang? Do good work. Be really fucking good at your job. Focus on being really good at your job. Be dependable. Know your shit really deep. Don't just be good at writing product. Be good at understanding why writing product a certain way is optimal. I've seen a lot of times where people just write product, move on, and don't give a shit about the code. And then eventually that code rots, someone else has to take care. of it. And so what ends up happening is that you lose reputation over time. It's like, it's not today, it's not tomorrow. You ship the product, great. But when you have to maintain it, 6 months later, it's like, oh shit, why is this all breaking? Uh-oh, this guy wrote the code. All that goodwill you just gained, no one's going to trust your code anymore. That's the way I would suggest. That's what I would suggest. Actually be very proficient at coding, understand your trade-offs, and understand your tech stack very, very well. This is what I would suggest you do to get promoted. All right, let's see what happened on Discord. I think there's some questions coming in. Okay, so let's see what people are saying in Disco. Okay, Tendy's posted a solution. You know, I don't want to look at this. I think I'm getting kind of tired from that. Let's see what people got for the live stream. Yeah, your ability to dive deep and understand what happens underneath the hood and why things are the way they are is super, super invaluable. You'll be able to do a whole lot more. You'll be able to build like some of these crazy tools, like a crazy platform stuff, and be able to have company-wide impact. That's ultimately how you become a staff software engineer, I think. I know there's like product staff software engineer, but really those people are very good at getting consensus across multiple teams. And usually you don't get there unless you've been at the company for a very, very long time. Whereas if you're a staff software engineer on something, let's say platform, and you're starting to deal with the fundamentals of your build system, that goes anywhere. You become a staff software engineer at Google, you'll be doing that at Facebook, Apple, wherever. You become a staff software engineer at Facebook, you're probably senior level at Google. If you're only focused on product, that is. Twitch interview is similar to Amazon. As far as I know, they operate on 2 different systems. You can actually fail an Amazon interview and apply for Twitch. So, yeah. Getting promoted in general, getting promoted at Fang definitely requires you to actually care about your work. And from what I've seen, a lot of people do not care. And that is a very big problem. And I mean, it's a big problem for them and the company, but it's not a big problem for you because it means that, again, you put a little bit of work to care about why things are the way they are, you will surpass everybody very, very quickly. Okay. All right, seems like people are leaving. I'm going to stop the stream for tonight. Hope you guys really like this. And if you really want more streams like these, let me know. Hopefully people in the future who book me for coding interview coaching agree to this because I definitely like this. I think it's very interesting to have this interaction go on. And I think that moving forward, I think just because of the sheer amount of value this provides, I think I might make it an actual policy or bump up the prices for private. Or I could do some freebies, I think the freebies are nice, but I really want to encourage everyone who's watching to make an effort to take everything I'm doing and talking about with absolutely, every single time I talk about doing things on a very basic level, I want you to be able to do it. I want you to be able to actually execute on these ideas, because if you still run into problems after that, talk to me about it. And if I think you are, you put in a genuine effort, I don't mind doing free sessions for you guys. Because at least I know that you will have put in the effort to really, really improve. And plus, once you start getting to that level, you start running into some very interesting problems with problem solving, looking at all these little assumptions that you're making, and you start getting to the nitty-gritty details of what makes software engineering really, really interesting and intricate. So I'm going to call it for a night here. Again, I don't mind doing these for free in the future, but I really hope that you guys take everything I'm saying to heart and will be able to apply them. So, all right. See you later, guys, and good night.